Hi, fourth graders. This will help you with your Module 4, Lesson 13 problem set. Now, mine doesn't look exactly like yours because I don't have a submit answer button. So you want to take a piece of paper and write down the answers in order, and that way you can go back in and type your answers in to your own assignment. So number 1 says, classify each triangle by its side length and angle measurements. Select the correct names. All right, so these two little lines here tell me that these sides are equal lengths. That line right there and that line right there mean that they're equal lengths. So when I have a triangle that has two sides of equal lengths, that is called isosceles. So you're going to want to click isosceles. Part B. Again, I have two angles that are the same size. And so when I look at the angles, I don't see the right sign, and I see that these are acute, so this one has to be obtuse. So I would click on obtuse. Part C. This is the easiest triangle to identify. All three sides are the same length, so that would be equilateral. Part D, in equilateral triangles, when all three sides are the same length, the angles have to be acute. They all have to be less than 90 degrees. So, and if you probably don't know this, but each angle in a equilateral triangle is 60 degrees. So that would make it acute because it's less than 90. Part E tells me that there are no lines here that tell me any of the sides are the same length. So when none of the sides are the same length, that's called a scalene triangle. And then this is the easiest one because it gives me a clue. When you see this little square in the corner, it's definitely a right triangle because right means 90 degrees. Part G, again, I don't see any lines here that tell me that the lengths of the sides are the same, so that has to be scalene. And then when I look at this again, there's no right triangle here, right angle, and so that means it has to be obtuse. All right, so number 2, it says triangle ABC has one line of symmetry as shown right here. What does this tell you about the measures of A and C? Well, I know that the line of symmetry, the opposite angles are equal measurement. And so I can type that in here. Actually, I don't think I can type on this, but I could write opposite angles are equal. Okay, and so you'll want to type that in your box when you can. And then DEF, triangle DEF, has 3 lines of symmetry as shown. How can the lines of symmetry help you figure out which angles are equal? DEF has a perimeter of 30 centimeters, label the side lengths. So I want to put answer A here. That's confusing. So I'm answering A here, and then B will be in the next part. So how can the lines of symmetry help you figure out which angles are equal? And we just did that in the first one, opposite angles. Opposite angles are equal. What that means is here's my line of symmetry. If I drop on the line, if I use E as the vertex, the opposite angles D and F are equal. If I use F as the vertex, the opposite angles E and D are equal. And if I use D as the vertex, the opposite angles E and F are equal. And so it's the same question, but now we're answering part B. If DEF has a perimeter of 30, label the side lengths. So how many centimeters is side DE? So let's think about that. Perimeter is when I want to find the outside length. So if I was standing at point E and I wanted to walk all the way around the triangle on the rim, the perimeter, how many centimeters or steps would it take me to walk all the way around? Well, I already did this and I know it takes me 30. So I walked around the whole thing and it's telling me that the perimeter equals 30 centimeters. I also already learned that in an equilateral triangle, all 3 sides are the same length. So I have 3 sides and they're all the same. And to find the perimeter, I have to add them. And I already know that the perimeter equals 30. So now I think to myself, what number plus what number plus what number that is exactly the same number can I add together to get 30? And if you still don't know what it is, you could always do this. 30 divided by 3. 3 because there's 3 sides and the perimeter is 30. And then I think once we do this, most of you will get it. You bring down the 0. And that each side has to be 10. So DE has to be 10 centimeters, EF has to be 10 centimeters, and FD has to be 10 centimeters because 10 plus 10 plus 10 is 30. And so it says type your answer in the number below. Each one would have to be 10. And now they're asking me for DF, and we know that they're all going to be 10. And we know that EF also has to be 10 because 10 plus 10 is 30, and that was our perimeter. So type in 10, 10, 10. Use a ruler to connect points to form 2 other triangles on your printout of the grid below. Now, you don't have the printout, so you just have to use your eyes. Use each point only once. That means I can't use these already because they're already done. None of the triangles may overlap. That means I can't take F and connect it to G and H because then I already used this point and then they're touching. 1 or 2 points will not be used. That means I don't have to use all the letters. Some of them won't be used. Name and classify the 3 triangles below. So they did triangle FJK by connecting the points. None of the sides are equal, so they call it scalene. And then the angle here has to be obtuse. All right, I'm going to connect D or A, B, and D. So if I connect A, B, and D, and I type that in there, triangle A, B, D, none of the sides are equal lengths. I could count 1, 2, 3, 4, 5, 6. This one's a 6. 1, 2, 3, 4, 5, 6, 7. This one's 7. And then this one would be even longer and a little bit harder to figure out because it's on the side. But none of them are the same. So this would be scalene. But what I do know here, and I can see that square right there, when I have that little square in the corner, it has to be a right angle. It has to be 90 degrees. So the measurement of the angle would be right. And you'll type that in on your chart, or actually you'd have to type it in your answer below. And then I can draw another one and I'll change colors. Now I can't use A, B, or D, and I can't use F, K, and J. So I'm going to use E, G, and I. And again, I'll do triangle E, G, I. And again, none of the lengths are the same. They're all different. So I put 3 different lines, 3 here, 1 here, and 2. They're all different. So that would be a scalene triangle again. But this time there is no right angle. In fact, this one would have to be obtuse. All right, so you want to type that in here. And now we're still using that grid, and it says, when connected by segments, they do not result in a triangle. So select 3 points from the grid above. So what 3 points could I connect that would not give me a triangle? So I think, this one, this one, this one. Yep, that gives me a triangle. This gives me a triangle. This gives me a triangle. In fact, this is the only one. If I connect these 3 points, they're all touching. That's not a triangle. It just gives me a line segment. So my answer is G, I, H. So you're going to want to check off G, H, and I. Why didn't the 3 points you listed result in a triangle when you connected the segments? And it's they don't connect because they are in a straight line. They're not all over the place. They're just in one straight line. They're actually just a line segment. So there we go. And can a triangle have 2 right angles? Let's think about that. Here's a right angle for my triangle. That's 90 degrees. If I draw another one here, that will give me another 90 degrees. But does that equal a triangle? Is that shape a triangle? And so the answer is no. A triangle can only have 1 right angle. If I try to make 2 right angles, it's no longer a triangle. So that's a lot for me to write with a pencil, but I could type that and I would say, no, a triangle, no, triangles can only have one right angle. And then if you want to add to the sentence, you could say, if I have 2 right angles, I will have a square, right? Because I would have to just connect that. 2 right angles make a square. All right, and so you'll type that in your box, and I think that's it. Great job.